Hey everybody, in this example we will be simplifying the trig identity you see on your screen right now. What we have, trig expression, what we have is a product. We have a difference, 1 minus cosine theta times a sum, 1 plus secant theta times just cosine theta. Now, I'm curious, take a second for you to think about what would you do, what do your instincts tell you to do? One thing that you want to be cautious of is you need to make sure you realize that the Pythagorean identities do not apply to this as it is right now because the cosine theta is not squared. The secant theta is also not squared, right? So just to reference a random card here, here is the Pythagorean identity. Cosine squared theta minus 1, sure, that's something, but cosine theta minus 1 is not. It is not the same if it's not squared. You can't just push that along and pretend that it still applies, okay? Same idea with the trig identity with secant, right? Here we have secant squared theta. Well, I can't just drop the square and pretend it's not different, okay? So what I'm going to do to start this one, and I hope your instincts kind of told you to do the same thing, is I'm actually going to use FOIL right over here. I like the idea of putting the secant and cosine together since they are reciprocals. It kind of cleans up nicely. We should know, hopefully really well, that secant theta equals 1 over cosine theta, right? So let's jump in and start right there. Oh no, I didn't mean to write on this side. This is my flashcard. We're writing on the other side. Good thing it's erasable pen. Okay. Here we are. So we are going to FOIL, distribute, first, outer, inner, last. I mean, every day of my life I learn more and more how many people have no idea what FOIL means, stands for, any of that. So let's just pretend A plus B. I shouldn't use A again. What am I doing? And C plus D. Obviously, they don't both have to be plus. Does not matter. That's just a general setup. F stands for first. What does first mean? Some of you think you know. You have actually no idea, do you? A and C are the first thing in each of the parentheses. A times C is the first product. So AC plus outer. O is outer. Oh, I don't know which way, what I'm writing where. O is outer. What's the outer? Well, the outer are these two. So if you picture your own head, right? Those are your ears on the side of your head, maybe not that big. And here are your eyes. Get it? Your eyes are inside of the middle of your face and your ears on the outside of your face. You're welcome. So outer is A times D. So AD is outer. Inner, like we see here, inner is B times C. BC in this case. And last is the last thing in each of our parentheses, B and D. So plus BD, right? So that's just a little review for those of you who have made it this far in life without really knowing what the heck FOIL is. It is not the stuff you cover your leftovers with. It is a mnemonic device to help us all multiply in the same order so that it's easier for us to compare our process, our work, our stuff like that. So this I'm not going to touch just yet. That's just going to stay. So first times first, I have 1 times 1, 1. Outer, positive 1 times positive secant is positive secant theta. Inner is negative cosine times 1, so minus cosine theta, or plus negative minus, same thing. Last times last, well, that's going to be, I'm just going to scooch this over a smidge, negative cosine theta times positive secant theta. Now, we're going to be smart about this. Secant is 1 over cosine. Cosine times 1 over cosine will be, anything times its reciprocal or turns into cosine over cosine, 1. And since it's a negative times a positive, it is negative 1. All right? Next step. Positive and negative 1. Cancel out. Adios. 0. Silent sneeze, sorry. Secant theta minus cosine theta. times, I'm using a dot this time, cosine theta. Now, I feel like usually we're used to thinking of distribution as coming from the left into the parentheses, but obviously it can come from the right as well. I'm not going to go through the trouble of rewriting secant as 1 over cosine, finding a common denominator. You can, and if you did that, great. I'm happy for you, but it's kind of heavy. So let's distribute cosine into here, right? Cosine times secant. Now, this time I can show a little bit more. Cosine times secant, or secant times cosine. I think I'm saying one thing, I'm writing the other. So secant times cosine minus, well, cosine times cosine now, right? So we did that, and now we're doing that. And that, I'm just going to go right ahead and write cosine squared. As we explained what happened up here, in case you weren't clear, secant theta is 1 over cosine theta times cosine theta, which is over 1, technically, minus cosine squared theta. This, you could take an extra step and write it cosine over cosine, but it's going to be 1 either way. 1 minus cosine squared theta. And then we have everyone's favorite identity, Pythagorean identity. And this, if you picture it in your head, think about it, write it down, whatever you need to do, equals sine squared theta. And there we have it. Hope you feel like a genius. Hope you're able to do that by yourself. Hope you enjoyed this video. If you got it right on your own, I'm proud of you. Put a thumbs up on the video. If you did not get it right and didn't even try it on your own and just followed along, copied me or watched, put a thumbs down. I don't care. My feelings won't be hurt. All right. So see ya in the next video, or you'll see me in the next video, and go to the playlist and pick out the ones you want to watch, and hope you're getting smarter.